Hey guys, and welcome back. Today we're actually finally going to be solving a system by graphing now that we've had all of these previous skills build us up. So our learning target, we're finally hitting it. Solve a system of two equations in two variables, and we're going to do this by graphing. Our success criteria, we're going to need to estimate the solution to a system by graphing. So we're going to use skills of being able to read the coordinate plane. Sometimes we may have to guess at where the point is intersecting and then verify it using how we checked solutions back in lesson 2. And then secondly, we're going to be able to solve just by graphing the system. So let's take a look at the first example. It says estimate and verify the solution to the system shown below. So first off, we need to remember that a solution to a system is where the two lines intersect. So I'm going to highlight the point that I can see the red line is crossing over the blue line. And I'm going to estimate where that point is lying. Now, in order to estimate this one, I have to look at the scale of the graph. They don't label all of the grid lines either. So I know that this grid line must be 2 because that's halfway between 0 and 4. Then this must be 6. So they're going by 2s. Same on the y-axis. This is 2 and this is 6. So if I'm going to estimate where this point lines up to figure out what the coordinate is, I'm going to take a guess that I don't have to guess at the x coordinate. I can tell that's definitely 4. But I'm going to take a guess at the y coordinate being 5 because that's halfway between 4 and 6. But I'm not just going to guess and call it a day. I'm going to verify my estimation. So I'm going to plug in, just like we did 2 lessons ago, I'm going to plug the 4 in for x and I'm going to plug the 5 in for y in both equations. So this equation right here, I have y, which is 5, is equal to x, which is 4 plus 1. Well, 5 is definitely equal to 4 plus 1 because 4 plus 1 is equal to 5. So the point that I guessed works in the first equation. But don't stop there. You got to check the second equation too. If you only check one of them, it may not be a solution to the system. So I have y, which is 5, equals 3 times x, which is 4, minus 7. So let's simplify the right side. 3 times 4 is 12. And then 12 minus 7 is in fact 5. So it worked for the second equation as well. So the solution to this system, I'm going to write this off to the side, solution is going to be the point for 5. All solutions should be written in a coordinate pair. Make sure you do that. Don't just write x equals 4, y equals 5. And make sure you put the parentheses around the coordinate so I know it's an ordered pair. Let's have you guys give this a try in your U-Try. All right, so here is what we've been waiting for. This is the actual example where we graph the system, we find the point of intersection, we verify it, and then we have the solution. So we're going to estimate the solution of the system by graphing the equations. So let's practice graphing, remembering that y equals mx plus b, and the m is the slope, the b is the y-intercept. So first, I'm even going to label, just in case we forgot, what the m and the b are for both of these. So of the first equation, the m is going to be 2, the b is going to be 0. Okay, because since I don't see a plus anything on the end, that means b is 0. And for the second one, I see that m is equal to -6 and that b is equal to 4. You may also want to represent your m's as fractions, which since these are whole numbers, it just means they're over 1. That way you can see the rise and the run. So I'm going to now graph these two lines. The first one I'll graph in red, so I have the y-intercept is 0. Then I need to rise 2, run 1. And I'm going to actually continue this pattern just so that my line is straight. If you use a ruler, then that will ensure that your line is straight. It's actually really imperative that you draw a straight line, or at least you give yourself many points in this, because we are human, we make errors, we all make mistakes, and when we're trying to estimate where the solution is, we need to be as accurate as possible when we're drawing these lines, or you may try to estimate something that is not the solution, and you're going to get very, very frustrated when you're trying to verify it. So now let's graph the other line. My y-intercept is 4, so I'm going to graph 4. And then I need to fall 6 and run 1. So let's see, 1, 2, 3, 4, 5, 6, run 1. There's my next point. Connect your dots. All right. So you can see now that the point of intersection is right here, and it's the way that I drew it, it looks like it may not be directly on a grid line. So we're going to need to make our best guess at what it could be. Again, when you graph, you're going to make lines that are not perfectly straight, that do not go through the points that you plotted perfectly. So you're going to need to guess numbers that are around where that point of intersection is. So actually, sorry, I'm going to zoom in. I'm seeing, if I line this up with the x-axis and the y-axis, I'm going to take a guess that this is about 0.5 on the x-axis. So I'm going to say 0.5 for x. And then I'm going to say I'm hoping it's at 1 for the y. Okay, so I'm going to verify if 0.51 is a solution to the system. Now, on your test, if you make a guess and it is incorrect, you will not get the points. So you need to verify and guess again if your first guess is incorrect. So I'm going to take my first equation, y equals 2x. I'm going to replace the y with 1 and replace the x with 0.5. Well, 2 times 0.5 is 1. So it did work in the first equation. Let's check the second one now. Y is 1. Equals -6 times x, which is 0.5, plus 4. Well, -6 times 0.5 is -3, and -3 plus 4 is equal to 1. So it worked in the second equation. So I know that my solution here, is 0.51. Let's have you guys give this a try. Oop, too far. Give this a try in your U-Try. Remember, you will have to change this equation into y equals mx plus b in order to graph. So I'm going to make that a note for you guys. Change this into y equals mx plus b. You also learned how to graph using intercepts. So if you'd rather use intercepts, you can do that as well. So this last example is a real-life application for why we construct and solve systems. So we have a photographer offers 2 portrait packages. The first package is $25 for 12 photos. I should get my highlighter out so I can highlight these major numbers here. $25 for 12 photos. And the second package is $30 for 12 photos. So those are actually initial values since it has the same amount of photos for each. You don't even have to regard the 12 photos. Those are standard. Those are given as the one-time fee, the actual package. So I'm going to also label the 25 and the 30 B because it's an initial value. It's what you start off paying. Then the other values are going to be the slope. I see 40 cents and 15 cents. I know it has to be the slope, particularly because of the wording. It says per, okay, or for every, for each, Okay, that indicates that it's a slope. So I'm ready to actually construct my system based on this real-life example. The first package, package A, the equation that represents package A would be y equals 0.40, or I'm just going to write 0.4x plus 25. For package B, we have y equals 0.15x plus 30. And the only way I'm going to be able to graph these is if I can see the rise and the run. So I'm going to change this one into y equals 0.4. 0.4 is equal to 4/10. So I'm going to write 4/10 x plus 25. I'm not even going to reduce the 4/10 because if you notice the scale of the graph, it's counting by tens. Okay, they skip one, then they go to 20, so it's going 10, 20, 30, 40, and that's on all the different sides of the axes. So I'm going to keep it in terms of tens. Now I have to change the second equation where the slope is a fraction. So y equals 0.15 is the same as 15 over 100. But if you take a look at the graph, it only goes to 40. So I'm going to reduce this down. Both 15 and 100 are divisible by 5. So that means this fraction is 3/20. So I'm going to have y equals 3/20 x plus 30. Now I'm ready to graph. The first equation, the y-intercept is 25. So that's about right there. And then we want to rise 4, run 10. Well, 25 risen 4 is 29. So that's just a little bit below 30. And then I'm going to run 10. So right below 30 and run over 10. And then connect the dots as careful as I can. If you can use a ruler, that would make your life a lot easier. So use a ruler when you have it. The second equation, I see y-intercept of 30. And I need to rise 3, run 20. So rising 3 is going to just be this little tiny rise and running over to 20. Okay, now again, these lines are not perfect. They're really not. So where these two lines intersect is kind of tricky because you have to think about how you drew your lines. Like when I drew these lines, I was not using a ruler. My points aren't perfectly plotted on the graph. So even though it kind of looks like my intersection's like way over here, I'm actually going to take a different guess. I'm going to guess somewhere closer to an integer value. I'm going to take a guess at 20. But I'm not sure about the y value. I'm really not sure about it. So the way I'm going to come up with the actual point that I want to guess where they intersect is I'm going to say x is 20, and then I'm going to plug 20 into one of the two equations to make a guess at what the y would equal. So if I plug in 20 into the first equation, I get y equals 0.4 times 20 plus 25. Well, 0.4 times 20 is 8. 8 plus 25 is 33. So I'm going to take a guess that this intersection point is 20, 33. I'm going to verify that in both equations. Now, technically, I plugged this into the first equation, so the first equation is already verified. I just need to verify the second equation. So I'm going to plug in 2033 into package B. So I have y, which is 33, is equal to 0.15 times 20 plus 30. Now if you were to type 0.15 times 20 in your calculator, you get 3. 3 plus 30 is in fact 33. So the point 2033 works in the second equation, and I derived it from the first equation. So the solution here is 2033. We should also make an interpretation because this is a real life problem. You should have a real life answer to a real life problem. So the x-axis represented the amount of prints. The y-axis represented the cost. So the point to which they're going to be the same, they cost $33 for both packages when there are 20 extra prints. Okay, so there's my coordinate answer and my real life answer to this question. There is one last question on this example that we did not answer yet. It said, explain when package A is the better deal. So package A, let's see, I did that one in red, and then package B I did in blue. So this one was A, and this one was B. Okay, so when is A the better deal? Well, we should think about what axis means cost. Well, the y-axis means cost. So wherever A is below B, so the up and down value, wherever A is below B, that's when it's the better deal. So I can circle this, or I'll highlight it in a different color here. I'll highlight it in purple. So from here back, that's when A is less cost than B. So we would say for anything less than 20 prints. Okay, I'm going to write that down below here. Explain. Package A is the better deal for less than 20 extra prints. Okay, so we did a lot of analysis on this example, and we had a lot of questions we had to answer. So refer back to this example as many times as you need and ask questions in order to try this on your U-Try. So that wraps up our final lesson on solving a system using graphing. And today we estimated the solution to a system when we graphed it. And we also actually graphed a system, created a system, graphed it, chose the point to which they intersect, and we solved it, finally, solved by graphing. If you are curious as to when we did this, we estimated in example 1 and 2, and then we also actually solved it in example 2 and example 3. If you have any questions, please let me know. You may now go ahead and start your practice.